Hi students, this is Noor El-Refaei, math teacher for both AS and A2 level. Today I'm going to start with the chapter 2, Logarithmic and Exponential function. But before I start with topic number 1, Logarithms and base 10, I have to teach you how to sketch the exponential function. I'm going to talk about just two cases. The first case where x, and the second case where I have a negative x. Now, the general formula for the exponential function is y equals a to the power x plus b, and I'm going to talk about the cases where a is more than 1. A is more than 1 positive and containing having a whole number. Now, when I'm going to sketch an exponential function, I'm going to discuss three major points. The first one is the asymptote line. I think you have a good background about the asymptote line, and you already drew an exponential function at O level. The asymptote line, the intersection point, and we're going to talk about the graph. Is it growth or decay? Let's start with the asymptote. The asymptote line always is the constant b that comes with the exponential parts. For example, y equals 3x. Now, where is the constant part is 0. So this is the asymptote line. The asymptote line y equals 0. Another example, y equals 5x minus 2, negative 2. This is the asymptote line. Intersection point. Intersection point when x equals 0. So I have to switch x and make it equal to 0. 3 to the power x equals 1. So the intersection line happens when x equals 0 and y equals 1. Growth or decay, when I look about x, now it has no negative sign. X having no negative sign, it will be growth. I'm going to sketch it. Simple. This is the asymptote line, y equals 0. This is the intersection point, 0, 1, and it's growth. Means it's going up exponentially from left to right. Let's move to the second example, y equals 5x minus 2. Where is the asymptote line? The asymptote line is the constant that comes with the exponential term when y equals negative 2. Growth or decay, it's x, not negative x, so it's a growth. And the intersection happens when x equals 0. Substitute 0, 5 to the power 0 equals 1. 1 minus 2, it will be negative 1. This is the asymptote line. Y equals negative 2. This is the intersection point at 0, negative 1. X having no negative sign, so it will be a graph, exponential growth. Okay, let's move to the second case. A is more than 1. I have negative x. I'm going to discuss the three major points. The asymptote line, always b. Now the intersection point happens when x equals 0. And growth or decay, because I have a negative x, it will be decay. Let's have an example. Y equals 4 to the power negative x minus 3. So the asymptote happens when y equals negative 3. the intersection point x equals 0, substitute 0, 4 to the power 0, it will be 1, 1 minus negative 3, it will be negative 2. This is the intersection point. Because I have a negative x, it will be decay. I'm going to sketch it. This is the asymptote line. Y equals negative 3. This is the intersection point, 0, negative 2, and it's decay. Going down from left to right. Okay, some students said y equals 4 to the power negative x minus 3. It's similar to 1 over 4 to the power x minus 3. And this is correct. And also it's similar to 1 over 4, all of it to the power x minus 3. I hope these two cases clear, students. And let's start with topic number 1, 2.1, logarithms to base 10. I'm going to sketch y equals 10 to the power x. Same points. The asymptote line when y equals 0, because it's plus 0. The intersection point happens when x equals 0. So 10 to the power 0 equals 1, and its growth. I'm going to sketch it. Y equals 0, the asymptote line, the intersection point 0, 1, and the graph is going upward exponentially from left to right. This is part A. Let's move to part B. Sketch the inverse of y equals 10 to the power x. We learned how to sketch the inverse function last year at A211. How we sketch the inverse function? First of all, we have to draw the mirrored line when y equals x. And I have to switch between input and output. 0, 1, it will be 1, 0. And I have to flip my graph around the mirror. This is the inverse function. Now, I have the sketching for the inverse function. What is the function itself? What is the inverse function for y equals 10 to the power x? If I look carefully, y equals 10 to the power x. The input is the exponential x, and the output is the value y. So when I talk about 10 to the power 1 equals 10. So when x equals 1, y equals 10. When x equals 2, y equals 100. When x equals 3, y equals 1,000. So the input is the power. In the inverse function, the output should be the power, x value. So how can I convert the exponential in a way that I'm not going to give you the power, I'm going to have the power. I'm going to give you y in order you give me x. I'm looking for the power. X equals the inverse of the exponential is using the logarithm. So I'm going to give you y, and the base is 10. This is the base. The input becomes output in the inverse, and y is the input instead of output. So when y equals 10 to the power x, the inverse, it will be x equals log y to the base 10. So f inverse x equals f inverse x equals log and x to the base 10. So the inverse of the exponential function is logarithm. Okay, let's move to question number 2. Convert 10 to the power x equals 45 to the logarithmic form. This is the power. So I'm talking about having the power as an output, not as an input. F inverse is x log. This is y, 45 to the base 10. Part B, solve 10 to the power x equals 45, giving you answer correct to 3 significant figures. To solve it, I'm going to use the calculator. To solve it, I'm going to use the calculator. This is the calculator. I have log. You see the log key? Log 10 base 10 45 equals 1.653. We're talking about 3 significant figures around to be 1.65. I think you see the key. I have 2 keys for logarithm. This is the first one and this is the second one, and we're going to use both over time. Okay, student, try to solve this question. Pause the video for no more than 2 minutes. Solve it and give me the answer to 3 significant figures. Okay, I hope you solved this question correctly. In this part, we're going to convert the logarithmic form to the exponential form. Log x base 10 equals 5.1. This is the base. This is the power. So to convert it to the exponential form, it will be 10 to the power 5.1. And give your answer correct to 3 significant figures. This is the calculator. So I'm talking about 10 to the power 5.1 equals 125,892. The 3 significant figure 156,000. Around to be 126,000. Any questions about converting from exponential to the logarithm and from logarithm to exponential? Now you have to know that the exponential, the inverse of the exponential is the logarithm. Any questions, students? Let's move. You have to learn some rules related to the logarithms. And I wrote it as a note. Notes A, B, C, and D. 4 logarithmic rules. We have to learn about them, and we're going to use them in the future to solve logarithmic equations, exponential equations, logarithmic inequalities, exponential equalities. The first one. This is simple one you learned grade 8 or 7. 10 to the power 1 equals 10. So if I want to write it log it 10 to the base 10, it will give me 1. According to that, log a to the base a, they are the same. Log a to the base a always equals 1. Another example, log a to the base a equals 1. Log 15 to the base 15 equals 1. First proof. The second one, 10 to the power 3 equals 1,000. Look carefully. Log 1,000 to the base 10 equals 3. I'm going to write 1,000 as 10 to the power 3. Can I? Yes, I can. Log 10 to the power 3 base 10. It should give me 3. And look carefully what I'm going to do. I'm going to move this 3 to be a coefficient. Can I do that? Yes, I can. 3 log 10 to the base 10. Log 10 to the base 10 gives me 1. So 3 by 1 equals 3. Let's check it by using the calculator. According to that, the rule would be log a to the base a. It's same as log a to the power b base a. Same equals to b. Fourth rule, log 1, write 10 to the power 0 equals 1 in the logarithmic form. So log 1 to the base 10 equals 0. Another example, log 1, I need to change the base. Not always need to be 10, maybe 9. Exactly equals 0, because 9 to the power 0 equals 1. So log 1 to the base 10, or whatever the base is, maybe 7, maybe 11, whatever the base is, it equals to 0. So log 1 to the base a equals 0. Always. Always. Third rule. Is the value of 3 to the power log 3 to log 8 to the base 3. Look, this is a power, not a coefficient. This is a 3 times log 10 to the base 10. This is a 3 to the power log 8 to the base 3. I'm talking about what is the value of. Now, I'm going to use the calculator. 3 to the power log 3 8 equals 8. Another example, 5 log 19 to the base 5 equals 19. So my answer will be 8. So a to the power log and b to the base 8. Look carefully here. And this is the same. They are the same. The answer will be B. Another example. Log, sorry, 11 log 23 to the base 11. The answer, it will be 23. Can check by using the calculator. 11 power 23. Okay, students, by using these 4 rules as a beginning, these 4 rules, try to solve question number 4 by yourself. Pause the video for 4 or 5 minutes and give me the answer, please. Hi, students. Did you solve these questions? Did you solve these parts for question number 4? I hope so. Now, I already solved part A for you. Let me explain it to the second time. It will be log 10 to the power 3 base 10. I'm going to move the power to be a coefficient. So it will be log 3 log 10 to the base 10. This will be equal to 1. 3 times 1 equals 3. Part B. Log 10 to the power negative 3 to the base 10. I'm going to move the power to be a coefficient. Negative 3 log 10 to the base 10. And it will be negative 3 by 1 equals negative 3. Part C. Log 10 to the power 1 by 10 to the power 2 over 3 to the base 10. Do you remember this? It's the cube root of 10 squared, or 10 squared 1 over 3, and it will be 10 to the power 2 over 3. The relationship is multiplication, so I'm going to add the 2 powers. So log 10 to the power 5 over 3 to base 10. It will be 5 over 3 log 10 to the base 10 equals 5 over 3 by 1, which equals 5 over 3. Part D. Log 10 to the power 3 over 10 to the power 1 over 2. All of them to the base 10. Because I have a division, I'm going to make subtraction. It will be log 10 to the power 5 over 2 base 10. The power becomes a coefficient, 5 over 2 log 10 to the base 10, 5 over 2 by 1 equals 5 over 2. I hope today's class is clear. Don't forget to solve exercises, especially book exercise. See you then in the second class. See you then.